Greetings, welcome to ArangoDB's Lunch and Learn. My name is Victor. Today's topic is going to be a recommendations engine. Let's dive right into it. So a brief agenda for today. What are recommendations engine? Why is it important? What are different approaches to recommending products, movies, and so on? Why is ArangoDB a great fit for this particular use case? And we'll also do a quick product demo. Okay, so what are recommendation systems, right? Recommendation systems are essentially, we have all used Netflix, we've watched videos on YouTube, we have bought products on Amazon, ordered food on Uber Eats. All these different businesses use recommendation systems as algorithms that are aimed at suggesting the most relevant items to users, whether it's the next best movie to watch, best products to buy, articles to read, so on and so forth. Okay, so in researching this particular topic today, I came across this interesting story, right? So there were two books. Once upon a time, there's this book called Touching the Void. It came out. It's about mountaineering in the height of winter. If that's the type of thing you enjoy, you can definitely check this book out. The book was very well received by the critics. It got a lot of rave reviews, critical reviews. However, it did not translate into any kind of commercial success, right? Far from being a bestseller. A few years later, another book came out called Into Thin Air. Now, for whatever reason, Into Thin Air picked up traction, right? It resonated in the marketplace, was an instant bestseller. Then Amazon made an interesting observation, right? People who bought Into Thin Air also end up buying Touching the Void, right? So what Amazon did was they started recommending Touching the Void for people who bought this Into Thin Air book, right? And then over time, Touching the Void started selling and then eventually became, a bestseller in its own right? To that it became a bigger bestseller than Into Thin Air. So the moral of the story is sometimes you do get a second chance in life. But more importantly, Amazon, by implementing a recommendation system, they got two bestsellers instead of one. Here are the different approaches. There's content-based filtering, there's collaborative filtering, and then there's a hybrid approach. Netflix uses a hybrid approach. So content-based filtering is essentially somebody watches a movie, they like that movie, we look for similar movies to this movie that they liked, and then use that as a basis for recommendations, right? Very simple. In collaborative filtering, what we're looking for is similar users, right? Similar users as in similar tastes. So in this example, we got two users, they've watched the same movies, movie A and B, right? And then we notice that David also has watched movie C, which Jill has not watched before. So we recommend movie C to Jill. And this approach is typically a graph-based approach. So here's an example of collaborative filtering, right? So you use typically a graph-based approach. The schema is just like what you will see in this diagram. On the right-hand side, you have users collection, you have movies. Movies contains attributes like title, actors, what kind of genre, a little description of the movie, and so on, right? Users would have attributes like age, name, and those sort of things, right? So, but anytime a user watches a movie, we create a new edge in the ratings collection that denote the fact that this user watched that movie, and by the way, he or she rated the movie 3 out of 5 or 5 out of 5, right? So using collaborative filtering, the algorithm is kind of at a high level, a 3-step process, right? So to recommend movies to a user, first of all, you find all the movies that user has watched and rated 5 stars. Okay, so those will be the set of movies this user likes. Then for every one of these movies, we find other similar users who have also watched these same set of movies and rated them 5 stars, right? So once we get a set of similar users, We then go to step 3 and find additional movies that are also rated 5 stars by the set of similar users. So very simple algorithm. Right, the algorithm looks like this. This has actually been covered before in a previous Lunch and Learn. You can see the 3-step process right here. There's also a collab notebook that's available. Just click on it. We'll share this slide deck. So essentially, for the input user, you look for all the movies that person has liked and rated 5 stars. For every one of those movies, you look for similar users who have also rated those movies 5 stars. And then for every one of those similar users, you look for additional movies that can be used for recommendations. Very simple. So here is how the query would look like. So recommend movies to users 1 using collaborative filtering. Is the dashboard for ArangoDB. The query step, you can put in what we call AQL, Arango query language. So this is a set of movies we would recommend. Here's how the graph would look like. Okay, so you have users of movies, and here's the rating edge, right? So users, it's a JSON document, right? It's a graph of JSON document, the vertices are JSON. The edges themselves are also JSON, right? It's just the movies 370. It's this title, it's a genre drama. This is a JSON object, right? A JSON array here, and the description, line studio. And then the edges are essentially also JSON documents. It denotes the fact that users 270 watched movie 370 and gave it a rating of 5. And there's a timestamp. Okay, so everything is a JSON document underneath, very flexible. So collaborative filtering is essentially saying, right, if you're about to recommend movies for users, let's say user 21, right? You can come in and say, user 21 has watched 558, rated it 5 stars, and so has users 270, right? So we can say, based on this, 270 and 21 are essentially similar tastes in movies, right? So we can say, okay, we expand one of these guys and then go off and look at other movies this person has watched and use that as a basis for recommendations. Okay, so however, if you look carefully, right, although these two users agree on this particular movie, they both give it 5 stars. With respect to movies 370, users 270 gave it 5 stars. They liked it a lot. And users 21 did not like it so much, right? So now you can say, well, are these two users are of the same taste, right? They agree on this movie, but they disagree on that movie. Is there a way that you can measure similarity, taking into the fact that, you know, users would like the same movies and they might actually dislike the same movie, I mean, other movies in exactly the same way? Is there a way to factor that in? And the answer is yes. Okay. You can use something called cosine similarity, right? So good, briefly review cosine similarity. It's an AQL function. It takes 2 vectors, right? So let's go to my scratch pad. Okay, so this AQL. I have 2 vectors, user 25 and user 298, 2 set of numbers. I put into a cosine similarity and I run it. It gives me 0.9149. That's what this I just ran right here, right? So how would it work in a graph, right? If you have 3 users in this graph, right, and they have a bunch of movies that they've watched in common, to measure similarity between 25 and 298, we look at all the movies they have in common, and we collect all the ratings into an array, into a vector, all right? So the 4 movies are this: 5325, 5325, and 4354, right? So we collect the 2 set of ratings together in 2 sets of array of vectors, and then compute the similarity. Likewise, for 25 and 13, they have 3 movies in common: 253, 343, right? So we put in 253, 343, and we compute the similarity, the cosine. Using this approach here, we can see that user 13 has a higher cosine similarity index than user 28 compared to 25, right? So the higher the coefficient, the more similar they are, right? And you can eyeball it, right? 2 is kind of close to 3, 5 is close to 4, 3 is close to 3. Right? So that's why this is such a high coefficient. Over here is slightly lower, and the reason is because if you eyeball it, right, 5 and 4 are close, 3 and 3 are, of course, a match. However, 2 and 5 are far away, further away. Okay, that's why it's of a less coefficient. Okay, so that's how we would compute similarity for users that share the same sort of quote unquote taste in movies. So now we know how to compute the similarity, the cosine similarity. How can we traverse a graph and compute these similarity as we go along? So here's the algorithm, right? Given an input user, and we call it user A, find me the 50 most similar users using cosine similarity. That's a lot going on, but essentially it comes down to this function being called cosine similarity, right? There's also usage of the collect to kind of aggregate and group by. Okay, here's the collect, that the variant of the collect statement that I'm using is this guy right here. Okay, so that's a collect statement, which is how you do aggregation and group by in AQL. I'm using the collect variable into expression, into a group variable, and then keeping a bunch of stuff. Okay. So what am I keeping? I am keeping the ratings as I go along, and then I plug into cosine similarity. So let's kind of walk through it step by step. Okay. So here's same traversal pattern, right? But I'm not using the collect yet. For users 25, what I'm doing is, so user A is the input user. Okay, user A is all the same. For the same movie, I'm listing out all the other users who have watched that same movie, and I'm gathering the ratings, right? So user A has 5 out of 5 for Return of the Jedi. User 231 has 4, so on and so forth. If you scroll down, you can see the movies change. Okay, now this is all good and well. However, cosine similarity, as you remember, takes 2 sets of vectors of numbers. Okay, so what we need to do is we need to tweak our query a little bit, and that's where the collect comes in. Okay, I'm collecting by similar users, which is my user B. These are my potential similar users, and I'm accumulating the ratings for B and A into an array. Okay, so let me, since I use a group variable, I now need to comment this out. There you go. Now, for every user, I'm collecting all the ratings for the for every shared movie that this user have with user A, and likewise, I'm collecting the vector of ratings for user A with respect to user 1. Now, with regard to user 100, they only have 2 movies in common. And so there's only a vector of 2 numbers. Likewise, there's also 2 over here. So the cardinality of the 2 vectors are exactly the same. Okay? So this is how we use collect to kind of aggregate and accumulate these ratings into a vector. So once you have the 2 vectors, it's fairly simple to calculate cosine similarity, right? You just plug the 2 ratings into the function. So the query looks like this. Okay, so this is the same query, right? We got our two vectors, right? Now all we have to do is to put it inside our function, and we might as well just go ahead and sort it. And since we calculate, we might as well just report it here. I'm going to hit execute. So because of a lot of users that only share 1 movie in common with user A, and the 2 values are fairly close to each other, like 5.5 and 3.4. That's why you see the cosine similarity of 1, right? But as you scroll down, you can see a more, as you go down to the 0.99, 0.8, and all that. In fact, what we can do is we can just filter out, just for illustration. There you go. We're showing only the cosine similarity of less than 0.9, right? So a lot more interesting data set emerges. Okay, so that's how you would find similar users using cosine similarity. This is the algorithm here. Next thing I want to talk about is content-based filtering. Now, while collaborative filtering is a popular approach for recommended items, it does come with a couple of drawbacks. The main one being what we call the cold start problem. So the cold start problem is basically when you have a brand new movie, a brand new item, right, that becomes available, unless the movie is well known, it's going to have very little viewing history in the initial stages, right? So that makes it kind of difficult to use collaborative filtering, to recommend it, right? This is where content-based filtering comes in, right? So content-based filtering, again, we're just looking for similar users based on other movies that the user has watched, right? So the other similar movies could include brand new movies with 0 viewing history. So a movie, we can certainly use a graph-based approach for content-based filtering, right? A movie has multiple features like actors, different movies could have the same actors, same directors, same genres, and we can model it in a graph and use one of the similarity algorithms like the one I just showed to measure similarity of movies, right? So it's all certainly possible. But what I want to do here is to showcase another feature in ArangoDB called Arango Search. Arango Search is essentially a full-text search engine written in C++, very high performance, and it comes natively integrated inside of ArangoDB. So you can think of it as quote-unquote an elastic search inside of a graph database. So, and one of the things that Arango Search does very well is relevance, right? Otherwise known as similarity ranking of items that you index. And the 2 most relevant algorithms that we support are called BM25 and TF-IDF. I'm not going to go through those things, but you can Wikipedia it. So here's how you would use Arango Search, right? So given a movie, so this is the AQL, given a movie, find similar movies to recommend using TF-IDF. So it's very simple, just call search analyzer inside of ArangoDB. Once you have the view is how you index stuff in, do a full text index of things inside of ArangoDB. So you call search analyzer, and here we're not doing anything fancy. We're just doing straight ahead given a movie description, find me other movies that matches, that are similar to this description, right? And using TF-IDF. Now you can do things more sophisticated, like concatenate, a little bit more sophisticated, concatenate the description with the actor's name, perhaps put in the genre and all that. We're just not doing that. Just want to show how well TF-IDF performs just based on movie description. Okay, so let's go to the query. Okay, so here's the query. So the first thing we want to do is look at this right here. So let's run it. Movie 5. Movie 5 is the input movie. It's a movie called Copycat. It's a crime, it's a thriller, and these are the results that we got. Right? So let's go see what's movie 5. Movie 5 is Copycat. It's a crime, it's a drama, thriller. It's about a psychologist, some female detective working together to take down a serial killer that copies other serial killers. Okay, fantastic. So it's about serial killers, right? So let's look at the result set. Right, so right off the bat, we have 1, 2, 3, 4, 5. Out of the top 5, out of the top 6, we got serial killers in the description. Right, so pretty good, I would say. Let's try another one. I want to queue up is 20. Movie 20. This is something called Angels and Insects. It's a drama, it's a romance. And again, let's go take a look at movie 20. That's page 2. Right here, it's about some drama in some British aristocratic family, right? So let's look at the result set. Not bad, right? The very first movie is a Jane Austen movie, Persuasion, also about aristocratic families in Britain. Result number 3 is Inventing the Abbots, something about aristocrat, right? So look at these results here, right? I can say not bad, but what's interesting is that Angels and Insects is a drama, it's a romance, but this thing here, the comedy, right? Miami Rhapsody made it as a, result number 2. Now, is it maybe it's worthwhile recommending, but if you wanted to, kind of be a little bit more granular and say, hey, these genres should at least have a couple of matches, right? If you want to do that, you could utilize, remember the genre is stored in the database as just a JSON array. We can use what we call a Jacquard index to kind of measure, see how close the 2 genres matches, right? So let's go to my queries again. Okay, there you go. I already have Jacquard index here. So it takes, Jacquard index takes, in this case, an array of strings, right? But it can be numbers, you can mix and match, it doesn't matter. There you go. So the two things matches, right? So if I were to come in and say action, right? So it's all of a sudden I break that match. Now you have a much lower Jacquard index, right? So here what I'm doing is I'm saying filter out all the movies that do not have a Jacquard index of at least 0.5. So now if I run this query again, you'll see Miami Rhapsody disappeared because it's neither a drama nor is it a romance, right? And interestingly enough, Inventing the Abbots, something about aristocracy, goes up to result number 2. Okay, so that's all about content-based filtering. Lastly, I wanted to touch a little bit about how we can do hybrid approach, because ArangoDB comes with both search and graph, and they're both accessible inside of AQL. This means you can very easily come up with a hybrid model that combines both approaches, right? Combines both content-based filtering with collaborative filtering. So here I just put in a simple example of how you can do a hybrid model. I've essentially kept the same content-based filtering using the search analyzer, TF-IDF, just straight up on the movie description. All right. Once I get, so this, given the movie, find other not similar movies, actually, there's a typo, find other movies using a hybrid approach to recommend, right? So I find all the similar movies, and then I just essentially put on the same approach that the first collaborative filtering algorithm uses. For every one of these movies, I find other users that have liked these movies 5 stars. And once I have these users, I look for additional movies that I can then use to recommend, right? So very simple. I'm not going to say this is something that that will fly in your use case, but so in summary, right? Why is ArangoDB? Why use ArangoDB for recommendation systems, right? So in short, the combination of be able to use a graph with full stack search inside of a JSON document store gives you a lot of power, a lot of flexibility, right? Recommending movies is going to be very different from recommending next best article to read. It's going to be very different from recommending social media personalities to follow, right? All these different use cases, it's important to have a platform that's both flexible and able to support multiple models, right? As well as having the ability to do all kinds of analytics like cosine similarity, Jacquard, TF-IDF, and so on, right? All that put together makes ArangoDB a great platform for recommendation systems. This is the end of the presentation. We hope you got some value out of this. Please share this if you think it's great content. Thank you for being here, and we'll see you in the next Lunch and Learn.